in this video, we'll discuss about Jacobians. Let us take one example. If x plus y plus z is u, y plus z is equal to uv and z is equal to uvw, then find Jacobian of xyz with respect to uvw. So here, to find the Jacobian of xyz with respect to uvw, we need to express xyz in terms of uvw. We note that the z is given in terms of uvw. Similarly, we have to write the x and y in terms of uvw. So z is given as uvw. The y plus z is equal to uv. So y we can write it as uv minus z, and the value of z is uvw. So this y in terms of uvw is uv1 minus w. Similarly, the x plus y plus z is equal to u. So we note that the y plus z is uv, x is equal to u minus y plus z, which is u minus uv. So that will be u is common, 1 minus v. So as z, we have x equal to u 1 minus v, y is equal to uv 1 minus w, and the z is equal to uvw. Once we express these xyz in terms of the uvw, which are the independent variables here, so find the derivatives of xyz with respect to uvw. So the partial derivative of x with respect to u, which also we can write it as dou x by dou u. Here it is. In this case, 1 minus v is the constant. The derivative of u with respect to u is 1. The xv is equal to u is a constant. The derivative of 1 minus v is 1 is 0, v is minus 1. So it is minus u. Xw, so there is no function w in x. So the derivative of x with respect to w is 0. Similarly, for y with respect to u. So in this case, v 1 minus w are the constants. The derivative of u with respect to u is 1. So the derivative is v 1 minus w. Y with respect to v. So here u 1 minus w are the constants. The derivative of v is 1. Y with respect to w, u v is constant. The derivative of 1 is 0, w is minus 1. So it is minus u v. Similarly, find the derivatives of z. It is z u is equal to vw are the constant. U is 1. Zv is equal to the z with respect to v, u, w are the constants. Zv, it is uw, and zw is equal to uv. So these are the partial derivatives with respect to uvw. The Jacobian of x, y, z with respect to uvw is given by xu. So all the partial derivatives of x in a row, it is yu, yv, yw, zu, zv, zw. So already we have calculated what are these values. So we will substitute the values. It is 1 minus v, x with respect to u is minus u, 0, v 1 minus w. Here it is u 1 minus w, and this is minus u. vw, uw, and u. So it is the determinant 3 cross 3. Evaluate this determinant. We note that from the third column uv is common. So let me take uv common from the third column. It is 1 minus v minus u 0, v 1 minus w, u 1 minus w. Here it is minus 1, and it is vw, uw 1. Evaluate this determinant. We know that signs of the determinant are minus, plus. So keep uv as it is. 1 minus v into multiplication of these two, which will be u minus uw. Here the determinant minus, and that minus it will become plus. It is uw. The formula of the determinant minus and minus u, it will become plus, plus u. Leave the row and the column containing that element. It is v 1 minus w, and here it will become plus, plus vw. On simplification, we note that uw get cancels. It is 1 minus v into u, plus here u v minus vw plus vw. Again vw get cancels. It is uv 1 minus uv plus uv. So once again uv get cancels. So just Jacobian is, so u into 1, it is u here. So it is u square v. Similar kind of the problem where x plus y plus z is given as u, and y plus z is equal to v, z is equal to uvw. They may ask you to find out the Jacobian of xyz with respect to uvw. So it is a similar type of the problem where the x will the z is given by, we can write x is equal to u minus v, and y is equal to v minus z. It is v minus uvw, and z is equal to uvw. Find its partial order derivatives. We'll get the Jacobian as equal to x, y, z with respect to uvw will be equal to uv. So this you can try. Thanks for watching.